Okay, so we keep studying the geometry of matrices, no? O sea, like a matrix is a transformation in the plane, no? O sea, what I want you to get, kids, is that we're doing something amazing. What you learn in like your normal math classes, o sea, is the concept of a function, no? Where you have x as an input and y as an output. And so you study like the graphs of f of x, no? But what we are doing right now is something super cool. Because what we're doing is we're having x comma y as an input, then we apply transformation t, and we get a new coordinates, no? Like x prime, y prime as an output. So, o sea, because the transformation t involves like a geometric transformation, we do not study like the shape of the graph, but what we study is like how the shapes change through a transformation t. For example, imagine that I have like this transformation. This is a beautiful question, no? So imagine that I have a like a square that has points here in the 1 comma 1, in the 1 comma negative 1, in the negative 1 comma negative 1, and here in the 1 negative 1 comma 1, no? So imagine that I have this beautiful square. If I apply this transformation, the transformation 3, 0, 0, 1, to each point, what am I doing? O sea, so for example, this point, the 1, 1, is going to go now to 3, 1, no? O sea, this point is now going to be in 3 in x and 1 in y. If I apply this transformation, o sea, like the new coordinates, o sea, you can do the multiplication, but I think it's very clear, no, that this will end up here in 3, 1. If you apply this transformation to the 1 comma negative 1, now it's going to end up here in 3 comma negative 1. O sea, like, try it. I think that you see where I am going, no? O sea, what is happening? Like, this is a stretching, no? O sea, the only thing that is changing is the only thing that is changing is like the horizontal axis. Okay, so what I want to show you, o sea, what I want to illustrate with this is to show you, like, if you have a, o sea, this is my pre-image, and this is my image. And this transformation, o sea, this matrix has a geometrical, o sea, that has a geometrical meaning, no? Eh, okay, and what is changing? No? O sea, I can tell you that the sides are changing, but also the area is changing. O sea, the area of this square and the area of this rectangle are not the same. They are related. And how are they related with the matrix? Okay, so I am gonna tell you, like, there is like this beautiful formula that says, o sea, if I have this matrix A, the determinant of matrix A is gonna be the area of the image, o sea, the area of the image divided by the area of the pre-image. So what is the area of this rectangle? This rectangle has a base of 6 and a height of 2. So this area is 6 times 2, 12. And what is the area of this square? This square has an area of 2 times 2, 4. Okay, what is the determinant of A? The determinant of A you can see 3 times 1 is 3. So, how is the area changing? Well, I do 4 times 3 equals 12. A ver, what type of questions could I ask you? I could give you, o sea, what you need to identify is that this matrix is changing the area of the shapes. O sea, and as big as this determinant gets bigger, the area is going to get bigger. If this determinant is between 1 and 0, 0 and 1, then it's going to get smaller. O sea, the area, you multiply by the determinant to get the area of the resultant shape, which I don't know about you, but for me that is very cool. Okay, and what happens for this type of transformations? So here I have a matrix. So this is going to change the area. This matrix is going to change area. But this vector is a translation. Translations are called what? Translations are called rigid motions because a translation does not change the area. So if I would like to ask you, how is the area going to change of this square after doing this transformation? The only thing that you need to do is find the determinant of the matrix. O sea, you would have to find the determinant of this matrix A, which is 2 times 3 minus 1 times minus 1. O sea, this is 6 plus 1. O sea, this transformation is going to change the original area by a factor of 7. If I were to apply this transformation to this square, I would do 4 times 7. That is the idea that you need to get from this skill, which I don't know about you, but it is super cool. You just need to get that idea. Woo, math!